Good afternoon, everybody, and welcome along to Data Platform Downunder. My name's Warwick Rudd, along with my co-host Martin Casserell. We're bringing you our second session for March in 2021. Our presenter today is John Martin, who's going to talk to us about SQL Server and network security. This session is being recorded and will be made available once the session has finished, and we've uploaded it to our YouTube channel on Data Platform Downunder. That allows you to come back at any point in time and watch this session, but also any of the previous sessions that we have recorded so far this year. So with that, we'll hand over to John and get today's session rolling. Did you want to share your screen, John? There we go, we can see your slide deck. John, we can't hear you.
How about now?
There we go.
There we go. It started out so well. Start recording and off we go. So the session today is going to be looking at SQL Server networking, network security. In my experience, this is one of the areas that tends to get neglected because it kind of slips into the gap between infrastructure operations and the DBA team or database team. So it's one of those that some places I've seen the DBA team's responsible for the OS and up. Other places it's the database layer and up, so SQL Server operating SQL Server software and up. So it's one of those things that if you don't get it right, it can be a real problem. We're going to talk through sort of a couple of specific scenarios about how we can look at what the sort of threat vectors are, and some concepts around how to make sure that we're in a better position to try and secure systems. So in the event of a breach, we're minimizing the scope that attackers can get through. So who am I? My name is John Martin. I'm Principal Consultant at JQM Consulting. My Twitter and LinkedIn are there. Feel free to connect with me on those. Microsoft Data Platform MVP. Done data platform for too long now. So moving on to the more interesting stuff than me, the content. Typically, when we start thinking about network configurations for SQL Server, we're typically thinking about things like don't use the default ports, hide the SQL Server instance, things that are well within our remit as data platform administrators. And these can be valid. I mean, anyone who's using or building SQL Server systems, administering them, whether they're on premises or whether they're in the cloud, there's some interesting benchmarks that are useful if you want to have a look. So something like the Center for Internet Security, so CIS benchmark, which is essentially a baseline configuration for helping you make sure your SQL Server systems are secure, recommends these turned on by default. And my personal view is it very much depends. When we start thinking about the default port for SQL, obviously it's well known, it's a common attack vector. People start looking for the traffic, they'll start scanning all those ports. But the reality is, if you switch out that port number for something else, unless you have gone to a unique port per server, then you're basically just sort of adding some complexity for yourself. So if you turn 1433 into 5232, for example, what you're doing essentially is saying, well, this is my new 1433. Like I said, unless you move over and manage everything, so it's absolutely unique, what's the point? because it is very easy to start sniffing traffic. It's very easy to, once someone's in the network, to start looking for the TDS packets that are flying around on the network. And if all of them are now transiting on a particular different port, then it's very easy and very discoverable. Okay, so I mean, just have a look at that interplay between, well, what is the benefit? What is the cost that it's going to incur for us to do these things? And are we just adding unnecessary complexity? As soon as you start adding unnecessary complexity into something, that's when you start making mistakes. That's when you start having issues introduced in the system that introduce those vulnerabilities. Similar sort of thing for hiding the SQL Server instance. It's all well and good, but what's the naming convention for your servers? So have you got SQL 01, DB 01, things like that? You're kind of giving the game away simply by the name of those servers, and anyone who can enumerate DNS, enumerate Active Directory, can start hunting things down and start inferring things very, very quickly from your naming conventions. And again, it comes down to you've got to use some more anonymous one, which then gives you some additional complexity into the environment. And unless in both cases you've got effective management structures around that, it can become very onerous to just turn those on and do it properly versus just ticking boxes, so to speak, for the purposes. So environments where I'm managing these systems, I don't do this. I stick with the default port, and I don't hide SQL Server instances because the naming conventions are such that the database servers are very easy to identify as they are, which is why it comes back to, okay, well, when we start thinking about security, what are the options? Now, specifically around the network piece for SQL Server, segmentation is an absolute key element here. So segmentation essentially is restricting access between devices so that device A can talk to device B only, really, or limiting it down as much as you can in that sort of scenario. You're essentially putting boundaries within your network that this is accepted traffic in this little bubble, if you will, and try not to come out of that. And then there's obviously traffic encryption as well, and that makes life a lot easier. If it's not securely locked down in the server, if it's out and about, if it's flying around, encrypt it. Definitely the way to be looking for those ones. So that's what we're going to be talking about specifically today. We'll be talking about predominantly network segmentation, some of the techniques, and some of the concepts to understand. And these are going to be just as applicable to cloud-based deployments as they are for on-premises deployments. So first things first is getting the right state of mind. Now, when we come to do anything with security, the key thing we need to understand really is when, not if. Okay, when are we going to be involved in a breach scenario? When are we going to be involved in a destructive attack scenario? When are we going to be involved in something bad happening? It's not a case of if, it's a case of when. It's going to happen. Accept it. Okay, if we move to that mindset of simply accepting that it's going to happen, then we're in a better position to respond to it effectively. We're also in a better position to think clearly about, okay, well, what are the risks? What is my risk appetite for managing these systems? Because that's then going to drive the levels of complexity that you will take and the amount of money you may be willing to spend to say, this is what we're going to solve the problem with. It also means that when it comes to happening, you're in a position to respond effectively. You're not going to be running around or waving your arms in the air and your hair on fire, or just sat there in a state of shock saying, well, how did this happen to me? It happens to someone else. That's typically what you see, is that in these sort of scenarios where something does come in, does breach, a lot of people just sort of, there's an initial state of shock. And it really comes down to saying, okay, well, if I prepare myself now, then we're going to be there. By doing that, it puts us in a strong position to say, okay, well, I know it's going to happen. How do I minimize the impact? That's what you're looking to do. Minimize the impact of a potential breach by making conscious decisions to look at saying, okay, well, These are the risks. These are the ones I can mitigate, given the budget I have, given the time that I have, given the skills that I have, given the people I have. These are the risks I can't mitigate for at this point in time. They're a low likelihood. They're a sort of medium high impact, that type of thing. Okay. It's all about getting that mindset. The other sort of element to it as well is secure by design. More often than not, you'll see, well, let's just get it done and we'll secure it after we've got it done. Let's just prove that it works and then we'll do the security bit afterwards, and then you never do the security bit afterwards. Secure by design is an important concept there. So always sort of put security at the forefront as one of your key sort of functional, non-functional requirement sections to make sure you're building secure systems. Now, you'll hear two sort of security, well, there's two security mindsets. One is secure by design, and the other is sort of security first stance. A security first stance is bad, put simply because if you put security above all else, you typically impact things like usability. And in that sort of scenario, you make it difficult to use. People actively try to circumvent it because people are inherently lazy. Being a person who, I'm inherently lazy. I don't like doing lots of things that are difficult. I will try and find a path of least resistance. If it barriers in my way, I'll try and circumvent them. It's just the way our minds work. So if you adopt this sort of security first posture, then what it means is that you can end up actually building systems that are inherently less secure because you're just ticking lots of boxes, you're making it difficult, people will actively do it as part of their day jobs. Whereas if you go secure by design and you're more requirements driven, that's what makes life a little bit easier for everyone. You find that balance, there's less issues getting built into there. So these are some of the mindsets, and it's not just when it comes to network security, it's to do with anything around the sort of security and implementation of the systems that we're managing, availability wise, so on and so forth. Then we come on to the concept of trust and trust boundaries. There's a concept essentially referred to as zero trust, where I don't trust anything that's coming in. Anything that's coming into this unit, I've got to be very explicit in what I'm trusting. There's a link in the slide, and I'll make sure these are available to the group. But essentially, you move to sort of trust nothing. What you're looking to say is, okay, well, unless I've explicitly set this up and say, well, this talking to this on this particular configuration, with these users, this service, things like that, unless you've explicitly stated it, I don't trust it. If I don't trust it, I don't want to let it anywhere near what I'm looking at dealing with it, whether it's an app server, whether it's SQL Server, whether it's a Azure SQL database, anything like that, okay? You want to be very, very explicit in what you're configuring, rather than sort of having a, well, we'll lock a few things out and this, that, next thing is nothing comes in unless I clear it. That sort of thing. Name's not down, not coming in. Okay, so again, just switch that mindset over and say, well, I'm not going to trust these users. I'm not going to trust that. Which again, when you think about the way we build our security models within SQL Server itself, we don't just let everyone in as sysadmin. We don't let everyone as DBO. Why should we be doing that with our network traffic in the context of the session today? So that's again something we want to start thinking about and understanding. So let me just check and see if we have any questions. Feel free to put them in the chat window, and I'll check in on it a couple of times, and we'll go from there. So nothing run at the moment, so on we go. So minimize that again. So we start thinking about network segmentation as a concept. And we're all probably relatively familiar with the concept of subnets. Okay, so when we start thinking about the systems we're deploying, you'll see some environments where it becomes a very flat network. Okay, where you have our database servers, we'll have our end user compute devices, the PCs, the laptops, the printers that are out on the floor, have our app servers, our app, web servers, or whatever, that type of thing, infrastructure servers, file servers, all of these. Now, this is essentially our network environment. Now, if this is one large flat environment, easy to manage, put it in the 10 range, got plenty of addresses, boom, off we go. but it's not great because obviously one huge network environment, I don't want my database servers sat there in the same network IP address range as the printer on the office floor. So this is where we start breaking things down. We start basically carving them up and say, actually, well, this is one network segment. This is one address space, if you will. So we'll wrap that around the database servers. We'll wrap it around the end user compute devices, and we'll wrap it around the application servers, the web servers, things like that. So in this scenario here, we've gone from having one huge flat network to now we've got one network structure. We've got 3 network bubbles, if you will. Okay. Now, obviously within this, you may want to take that down a little bit further to try and segment maybe production, non-production, that type of thing. Okay. But depending on how far you go, network segmentation at a very fine level by using subnets can become, again, very complex. So again, it is about finding that balance, and we'll talk about a way to look at sort of a more granular segmentation process later on as well. But again, comes down to, in this case, we're going to look at the 3 groups for our systems there. We've got our users network as well. So in this scenario, we're talking about 192.168.0, 1, 2, and 3 network segments running with a 24-bit net mask. So this notation, you're probably more familiar when you put them into your network interface card configuration on your servers, if you're running static IP addresses, things like that, or you're doing an IP config. When you look at the 192.168.0.1 and your subnet mask is 255.255.255.0, that 255, the 3 of them essentially is 24-bit mask, which is what the 24 on the end of these means. Essentially, it's a CEDAR notation, which is, if you're using Azure or if you're using AWS or things like that, becomes the way you're predominantly talking to or configuring the network segments and such like when we start setting them up in Azure or whatever. If you want to do some more reading around that, it makes it a lot easier to try and figure out what your network segments are. So we've got our 3 or 4 bubbles, if you will. Now, how do we control access? Well, this is where our good old-fashioned infrastructure firewalls come into it. Okay, so essentially, we've got a firewall in the middle there, which is controlling and managing traffic between all of these 4 bubbles. Okay, now in this scenario, if you've obviously got big ETL servers sat over in one segment and another, you've got to make sure that the firewalls are capable of handling all the traffic throughput. And it's a scenario where you can introduce a bottleneck, you can introduce these single points of failure, if you will. So make sure when you start implementing this sort of thing, we're dealing with highly available configurations sat there in the networking layer to make sure it's all as it should be. Okay, so we'll work through with those ones. What this means is essentially that we can now start saying with the infrastructure firewall, because we've got these network segments, okay, in order to get from one to the other, we've got to transit the firewall. So when we come across to this and we say, actually, I want to set these 2 app servers to be able to speak to, this is their database server, or this is the database we want them to speak to, we can actually define those rules here in the firewall. So we're now in a position that we're starting to move to this. I don't trust anything coming in from here to here unless this firewall's got the explicit rule to say TDS traffic, so traffic coming from these 2 sources on port 1433 into this target. Unless that's the way it's looking, it ain't happening. Okay, if for example these 2, where is it? There we go. If these 2 servers here try to talk to this server, it's not going to happen. Firewall's not going to let the traffic in from those devices. Okay, so just need to be setting it up. Now, the complexity you're looking at here is typically we're doing static IP addresses. That's the easy way of setting the firewall rules up. There are more complex ways of doing it. When it comes to things like, if for some bizarre reason you're using DHCP within your your infrastructure estate on the back end for your servers, that's when it can become a little bit more complex, and there's some more things you need to take into consideration. Now, moving on to think about how, where's that gone? There it is. To how do we get our network devices to talk to our database server? Now, this is where we have an interesting one, because if we turn around and say if it's an application, for example, we want to let these devices into here. Typically with the infrastructure firewalls, it's IP address based, so this device with this IP address can talk to this IP address on these protocols. If, for example, we're dealing with a scenario that this network segment is all DHCP, for example, then a lot of the time what you're saying is in these firewalls is that this entire network segment can talk to this server, because you can't easily lock it down and say, well, this client device is always going to have this IP address. So this is why when you see people, when you start thinking about giving users access to the ability to query databases, you've got to be very, very careful, because if I was to say, well, Martin over here wants to talk to this database, if this entire segment is DHCP and I want to let him have access to this database, for example, I've got to open up this entire network segment and traffic from it to that database server. So long as I've got if I've got a strong ACL, so only Martin's account has the relevant permissions on that target server, that's great. But if I get a misconfiguration and my ACL suddenly become a bit more permissive, we put the wrong AD group in there for some unknown reason, someone drops in the sort of Active Directory users group, then suddenly everybody can gain a sort of network level access, but B, you've also then got that permissiveness in the connectivity and the authentication. So just be careful with that one, as an aside. So come back to this scenario here, the client device talks to the app server, and then essentially it's the application server which then talks to the database, which is the way we can look at doing it. Obviously, depending on what we're dealing with from an authentication perspective, we're using pass-through, or we're using things like application pool accounts in IIS. We just need to be cognizant of how we're setting up our Active Directory scenarios as well. Okay. So let's see if we've got any questions so far. No, just a couple of comments, which is good. So this is all well and good, and this is what we're speaking about with network segmentation. We're starting to build those boundaries. So what it means is, again, if we end up with a scenario where something happens in here, someone opens a malicious email, we end up in a scenario where things cannot traverse easily into this environment here. So, for example, what we want to avoid is this system here. Pen. Let's try drawing here. So this one here being able to come straight across to here. So if that gets breached, then that becomes the problem. Okay. Whereas if we go to the next scenario, what we want to watch out for again is essentially what's referred to as lateral movement. Okay, so what we described there is if we've got someone getting their laptop breached by the ransomware or something like that, that could, depending on what your configurations are, move laterally within its network bubble. What we want to do is prevent that going into our other ones. In the case of a database server or any sort of system, file servers, things like that, if you get encrypting ransomware, that's the bit that if it propagates and spreads through your network, you end up in a scenario where it can be very, very painful. What you want to do here, and this is one of the areas where, because we're within that bubble, we're not actually traversing out to, the way the networking works is we're not actually going out to the network firewall, or the infrastructure firewall rather. So when we're in a position where we're essentially saying, once you're in that network bubble, how do we lock this down? What do we do? And this is where we start thinking about a topic that's essentially referred to as micro-segmentation. So we take that boundary and we move it down. Okay, so this is where we're going to bring it down a little bit further. And in this particular example, we're going to start dealing with the the actual database servers themselves. So the key objectives for micro-segmentation and network segmentation overall essentially is it's all about preventing lateral movement. We're looking to say, okay, if something does get into our network, that it can't move from user compute end user land into our server network segments. If something does get into our server network segments, what we want to look at then doing is preventing movement between those server devices. Okay. Now, how do we look at doing that effectively? Well, that's something we'll look at in a moment. But essentially, this comes down to, again, adopting that mindset that I was talking to you earlier about, which is trust nothing. Because once it's in, if you've got this sort of, you've got things like the admin shares open, and you've got older SMB versions in play, you've not got anything there. There's a lot of network-borne attacks which use and piggyback off an awful lot of our standard administrative tool set that's going to be present within the environment. Okay. So again, we want to make sure that we're locking this down. We're saying, okay, well, we're not going to have full access. We're not going to let everything in. Okay. And then we want to really start documenting and configuring our network so that only sort of workloads that need to speak to each other do speak to each other. Now, this is an interesting one when you start thinking about the applications and the systems we're deploying. It becomes very, very interesting to think about how it's easy. I've got my app server. My app server talks to my database server. Okay, that's great. Now then we start stepping back and say, okay, well, what about our monitoring software? Monitoring software is interesting. Do you have agentless or agent-based monitoring? Because there's always going to be a number of nexus points for that. So you're essentially looking at a huge funnel for monitoring solutions. So something like SCORM or SolarWinds or what have you, or Tivoli. Essentially, you're going to have potentially something out there on every machine talking back to management servers, which then in turn feed that back to their database layer. If you've got an agentless monitoring solution like SQL Sentry or Redgate or anything like that, you're going to have one central server that's going to have to reach out, and it's going to try and communicate with those remote servers. So when it comes to that side of things, treat that as its own specific, special little world. Those are the things that typically have the keys to the kingdom, and if they get breached, that's when you're in a bad position again, because they do, by their very nature, tend to need very high privilege rights and have access to a huge amount of stuff. So you're in a position where if that machine gets compromised and the credentials are compromised on it, people can pretty much walk around your network with all of the key protocols that you need to be able to do something mean and nasty. Okay. So when we start thinking about it, it's not just our client-facing stuff that's the risk. I mean, as was shown with the SolarWinds attack, it can be our own monitoring tools and things like that which are used against us. So coming back to how we effectively secure those and how we analyze those and do all the monitoring around that is going to be very, very important as well. And treat it as its own discrete workload. Okay. So how do we start looking at micro-segmentation? Once we're outside of the ability to use those infrastructure-based devices, that's when we start looking essentially at software-based devices. The software-defined networking, we've got firewalls on the machine. So start with the firewalls on the systems. Everyone maligns it, but Windows firewalls are actually quite good. Historically, it's been a right pain in the ass to try and manage effectively at any form of scale. It's never been the easiest thing in the world to work with. It's got a lot easier to do more recently. The PowerShell tooling that's available around the Windows firewall now is actually very, very capable, which allows us to do effective remote management. You'll see some people doing things like setting rules with Active Directory, for example, with the firewall. That's not a great scenario because, again, you're dropping into a one-size-fits-all scenario, or you're trying to build something very, very complex. Essentially, group policy in the context of firewall is a massive sledgehammer. Okay, it's like, this is how it will be, bang. Or you've got to go and build a very complex AD structure. And again, as I said earlier, you start building in onerous levels of complexity, and that's when things start to go wrong. Okay, so when we start thinking about it, how do we manage the Windows firewall effectively? If you don't want to spend any money, PowerShell. Get familiar with it. It's a very, very useful tool. The commandlets are now built into the system. It's very easy to do. If you're using Linux, I think you've got IP tables and you've got various other options there as well. There are additional sort of third-party technology solutions. So if you're running on premises, VMware's NSX can be very, very capable, but again, you've got to put that investment in up front. Then you've also got some complexity around who manages it. Is it the VMware admins? Is it the networking team? It's some form of hybrid operating model. And again, introducing an element of complexity, understand what the operating model is, understand who has what level of responsibility, because again, you don't want anything dropping down the cracks. Be careful with that. You've got tools like Illumio, which is a fancy way of managing the Windows firewall on endpoints, and can do a lot of analysis for you, things like that. And then you also need to look at things like potentially some of the Cisco solutions. All the big network vendors have got software solutions as well that will help you do sort of access-based control. So there's links into Active Directory, all that sort of stuff that will allow, okay, well, this person talking, or this account talking to this system on these protocols. So you can bring it down to that sort of granularity as well. So depending on what your budget is and your level of, level of maturity of managing these sorts of environments, don't just go from 0 to fine-grained access control through using the Palo Alto or Cisco equipment that runs straight into Active Directory, because making that jump, going from one extreme to the other, can be quite jarring. I'm always a big advocate for rapidly iterating and taking those small steps to get to where you want to be, rather than sort of doing the huge hop, skip, and jump of I'm here, done. Okay, it's how we sort of go through that, and it's just eating a pizza one slice at a time sort of thing. Okay, so with that, let me just check and see if we've got any questions in the chat. Okay. So we'll have a brief look now at one of our demos. I'll just find the right virtual machine. Here we go. So I've got a very basic network, very basic configuration set up here. I'll just zoom in a little bit more so we can see it better. But essentially, I've got just a SQL 01 server, which we're going to demo this one on. And I'm doing this from a Windows 10 client, which is also within my network. I've just gone for, I installed these this afternoon. They're completely sort of vanilla OSs. They're straight out of the box. I've not done anything around configuring the firewalls additionally or anything like that. So as you can see, I can't ping the server. If I make that full screen, what we can do is actually just fire up Management Studio. Now, at the moment, we have no firewall rules on the other side. Let me just open Management Studio and we'll try and connect. There we go, SQL 1. As you can see, unable to connect at the moment, so let's minimize that. So I'm just going to set my variable, so I don't have to do that every time. So essentially what I'm going to use here is get the network firewall profile. So when we start thinking about the way that we're going to use Windows Firewall, oh, don't tell me they've got it messed up already. This worked earlier. Just test. my machine went to sleep. I left it on, and it looks like. Let's see if I can do it. Yeah, okay. Give me 5 seconds just to quickly get my Kerberos authentication working again, and I'll be right back. So whilst I'm just going to quickly get my domain controller working again. Does anybody have any questions? Okay. Let's just do these quickly. Let's see. So, got one coming in now from Mike. How do you decide how restrictive network security boundaries should be from one extreme perimeter security right down to the other of sort of port-to-port, server-to-server firewall rules, Windows firewall on individual SQL servers, IPsec, restrictive routing tables, etc.? Where do we find the balance between secure communications and security being restrictive that DBAs, whoever, start pulling their hair out every 5 minutes? I know what you mean. It's an interesting and difficult scenario. This comes back to, like I was saying earlier, about just taking it a little bit at a time and bringing things in incrementally. So initially go for make sure you're running at the large segment scale to start with, for example, and we'll say we'll start with server-to-server comms. That's the one that we need to be aware of. Now, one of the interesting ones there is, as I said, about management, your sort of workloads. What you want to make sure is you've got secure zone where you're doing administration from that has the right level of access to get to where you need to get to. We should never really be using a SQL box or whatever as a jump server. It should be a case of, if we're logging into a server within our network segment, we shouldn't be then doing administrative actions on another server from there. So it's about understanding our own operating procedures and operating practices. And then what we want to say is, okay, well, if we do get to that one, what am I going to do there? Do I want to manage all of my machines, for example, with DBA tools from my management jump server? So I need to have that system to have the appropriate levels of access. Then it just comes down to making sure you've locked it down, essentially. Are you going to use MFA? Are you going to use what sort of mechanisms to secure access there? It's about building those layers in. Network security is only one layer of security, and it's a let's see, is that domain controller coming up yet? Not just Azure that had a wobble today. There we go. That's good. That's coming online. So yeah, so it's how you find that balance? By getting there. I've worked in environments where there's nothing, we've had to go to something. And then I've worked in environments where it has been incredibly draconian, where it has been a scenario where I've had to use 3 layers of security to be able to get to the management server, to then get onto another system to be able to do some work from there. In those scenarios, it becomes very, very difficult, especially when you layer in things like privileged access management, which means that I don't even know my own passwords and they get cycled on a regular basis and stuff like that. That again can become problematic. So my domain controller is just coming back online. Let me just restart my other 2 systems, and then we will hopefully be back in action. So let's see how that one goes. So yeah, sorry I can't give you a clear and definitive do this and it'll be fine. As with anything, there's a very big it depends in there. But typically what I would look to do is abstract as much of it as way so it's transparent as possible. So things like IPsec should be handled at the infrastructure level wherever possible. So certificates, things like that. There's a lot of management tooling that we can get now that will make our lives a lot easier. So to give you an example, I recently worked with, let me just quickly do this one, with my team, and we deployed 100 or so TLS certificates across our SQL estate. And we did that in a day. It's going to be fun when those certificates have to rotate, but we've got monitoring in place to do that. So again, that's what we need to look at there. Okay, apologies for the issues there. Right, let's fire up ISE. Hopefully it's going to remember that it had to, yep, give me those. So let's see. That looks better. Thank you, domain controller. So coming back to the demo now. Network profiles. We've got 3 of these on our servers: domain, private, and public. Okay. Now, obviously, in the domain environment, that's the one we should be looking to use. If you're using some of the older failover cluster instances, then obviously you're going to have heartbeat networks and things like that, which may not necessarily be domain, public, private. Make sure you set them accordingly, because when you set your firewall rules at the Windows level, you basically sort of line them up and say which profile do they apply to. One thing I would always do, as an aside for what we're going to have here on this demo, is on the public network profile is have a deny everything rule, quite simply. Especially in virtualized environments, what you want to be avoiding is the scenario where someone plumbs in a network card by accident onto a virtual machine, because we're people, we're fallible, we make mistakes. Put that in, because Windows doesn't know what it is, it sticks it in as public. It just becomes another vector that people can come in out of. You're very tightly controlling it, and you know that everything should be coming in on domain one, for example. If you're using FCIs, you've got a private one for heartbeat, until you move to one of the more recent OSs and things like that. If you've got any legacy in the environment, then essentially what you can do is say, okay, well, if this suddenly does materialize for whatever reason, then I just want you to sinkhole all the traffic. Okay, I'll deal with the issues afterwards. So just set that one to there. But also with these firewall rule profiles, we can actually generate 1 log per profile. So we can actually start doing some analysis on what those are. I think the maximum log file size, I think it's 32 megabytes. So if you've got a very active system that's doing an awful lot of activity, you can cycle through that very quickly. So that's where having something like log analytics or SCOM or something like that that's reading the firewall logs. So for example, Azure Sentinel is a great way of collating all of those into a single place to actually have a better look at what's going on. So what we can do is, those are our profiles. Now we'll have a look at what the rules are. So there's a lot of rules that come in straight out of the box, quite literally. So things like media player, sharing, all that sort of stuff. There's groups already in there, and depending on what you're doing and what have you, some of these will be turned on, some of them won't be turned on, depending on what your server's doing, where it is, and what have you. So there's a lot in there as it stands, but nothing for SQL Server. Okay. So when we start thinking about building our rules up, anyone who's seen some other presentations will know that I'm a huge fan of infrastructure as code. And what we can do is, because essentially we've got these firewall rule commandlets, we've got essentially we build a hash table of essentially what the rule governance is. Okay. So in this sort of scenario, I could define all of these as parameters. I can store it all in a in source control or something like that. So that if I have to rebuild my permissions, if I have to rebuild my firewall configurations on a server, things like that, I've got it in source control. If I want to do a baseline of what they should be, I've got them in source control. And we'll have a look at what the next step on from doing this raw PowerShell is shortly. Just talk through what we've got here in this rule. Essentially, we've got a fancy name for it. We've got a display name for it. Always put a little description in there. Makes life a little bit easier. Try to group them wherever you can, because one of the things you can do is just when you're doing things like the get firewall rules and things like that, say, give me everything for the group. If you want to turn them on by a group, it just makes life a little bit easier if they're all logically grouped together. We're going to say we'll allow, it's in inbound. It's on the domain profile here. It's not on the others, so I'm not going to let anything in from the others. It's going to come from 192.168.0.3, which in this case is going to be my management machine. So when we start thinking about this, you've got the option. You don't have to specify explicit IP addresses. So when we start thinking about letting things in where we've got dynamic IP addresses, you can set address ranges, you can subnets, that type of thing. And this again comes back to that layering approach where we've got an infrastructure firewall performing certain activities and then the local one here. Now, one of the things when you start thinking about the layers, just remember security is not like an onion, as many people say, because onion layers are typically solid all the way around. Security layers are more like Swiss cheese. Every single layer has some holes in it somewhere, and it's just making sure you've got enough layers positioned in such a way that they don't line up to let everything through. Okay. So, like I say, this one I'm just going to be explicit because for the demo environment here, I'm doing this one. It's on the TCP protocol on this particular port. Now, this is an interesting one with the Microsoft Windows firewall on the machine, is that I can actually bind the rule to a service. So, because I'm saying this is a SQL Server firewall rule, traffic coming to this SQL Server, if this service is not running, do not let traffic in. And again, it just adds a little bit of sort of belt and braces approach to us on what traffic can and cannot come into our environment. Okay. I'm setting up as false for enabled by default. I tend to be very explicit in what I'm doing is I'll deploy it, I'll check it, then I'll enable it. And the sim session is how we're going to actually talk to the remote server. So in this case, I'm saying for SQL 01. Okay. And obviously I can parameterize that if I wanted to. So if I take this, we'll run that one. That's our 1433 traffic. If we, for example, we've got AGs, you'll want to set the rules up. Now this comes back to that. Are we going between subnets or are we going within our subnet? So obviously within AGs, we've got to do synchronization traffic between the servers. Now, if they're locally resident in the same data center, typically they're going to be within the same network segment. If you've got them going cross data center, that's where it gets a little bit more interesting. Have you got stretched VLAN? So you've got one address space that spans both sites, or all of the sites, so it's one logical network, if you will. Or do you go multi-subnet? So just bear that in mind. But essentially, because we're doing this and we're down now at the client level, or say with the endpoint level, I want to be able to set that rule up as well. So if we run that one, we set those up. And if I run this, we can now see right down the bottom, we've got our two new rules, 1433 and 5022 in. Okay. And then we can start looking at, okay, I want to set these up. And now this comes back to what I said about using a group. So I'm going to say, give me everything in the SQL Server group, and I'm going to turn it on. Okay. So, yep, now they're on. So if we have a look at those, and again, using the group, I can pull that back. I can format them as a table. I can see now that those inbound ones are up and running. So I've got the ability now by doing this through PowerShell effectively to say, I want to deal with this on my local endpoint, piece by piece, but I don't want to have to log in and do it with, I don't want to do it with Active Directory, group policy. I don't want to have to go in and manually configure it. I don't want to have to use the old NetSH pieces, things like that. I've got these firewall commandlets, and they make our lives a lot easier. Okay. So what we're looking at there is, if we come back to we've got another demo first actually as well. So we start thinking about, where's it gone? Come on back here. The other options we've got, that's all very good. It's a little bit more involved. It's great if we're doing it interactively, or I set the script up and I get it to do all the work. But if we clear that up, what's the option for if I actually want to make this and automate it more effectively? Well, this is where PowerShell DSC comes into it. Okay. Now, this is where our desired state configuration essentially allows us to really take the infrastructure as code concept to the next level for this one. And I essentially define my firewall rules, much like I did in my splat for the PowerShell commandlet, where I can actually come up with an entire firewall configuration for a server. Again, I can store that somewhere securely, but essentially what I've got, this is a baseline of what it is. Now I'm going to do what's referred to as a push configuration. So I'm going to define that here, and then I'm going to push it to the server. PowerShell DSC has also got the ability to do what are called pull servers. So essentially what I can do is I can configure an SMB or an IIS, if I want to do it all on premises server, where I can publish these configurations and I register those endpoints into that pull server, and they will pull that configuration down on a regular basis. And what that means is that through the course of the day, every 15 minutes or so, they will look at the configuration they have, they will compare it to the configuration that they're supposed to have, and it will remediate it as needed, which means that you can start scheduling the deployment of firewall updates, much as you would do a push to the infrastructure firewalls. You can do the same for your individual servers themselves. So again, we can start managing these more effectively at scale. So if you've also got the app servers and stuff like that coming into it, PowerShell DSC gives us that ability to manage a much larger estate more effectively. So this is a very, very basic configuration. What we're looking at here is the configuration that says exactly what we said before. So if we go through, and I'll just define that configuration, generate the configuration file, and then what I'll do here is actually push that configuration out. So you can see here we get the full log of the information. It's going and saying, okay, well, have we got a rule? If we don't have a firewall rule, go and create one, so on and so forth. Okay, so it's basically using the same mechanisms that we did before. So if we have a quick look, we can now see there's our DSC rule, much the same as the one we just created a moment ago. So likewise, what we'll do is we'll just quickly come in and we'll create the AG replication one, generate the firewall rule, push that one out as well. Okay, so nice and easy. Okay. Okay, so have I created the wrong one again? Yes, I have. I've done both of them the same. So now we've got it turned on. So what we can see here is that just by going from one to the other, we're up and running. So again, this just makes our lives a little bit easier for, well, let's push these all out nice and quick and easy. We'll define them all. So I can define that whole rule set in one place. So I've just got one file to need to look at, that type of thing. Okay, so brief demo summary. We've got the PowerShell commandlets, allows us to do it locally, remotely. So we can use things like Azure DevOps. We can use PowerShell DSC as well, if we want to take that. So we can do the automation and coordination of that distribution of rules for us. So that makes life a little bit easier. Now, a couple of the other topics we want to quickly touch on are TLS encryption, IPsec. Going to focus in on TLS for this one. IPsec, like I said, should really be dealt with at the infrastructure level, away from us as database administrators. TLS encryption is something that is well within our control. One thing that is advantageous is to work with whoever coordinates and runs the certificate authorities within your environment, and have them set up a template for a certificate request. Okay, because then it makes life a lot easier if you've got a specific certificate template that is solely for SQL Server TLS that ticks all the boxes around what you need for the request structure, and then it makes life just so much easier. You've got that there. When you come to do the TLS piece, just remember as well, if you're doing standalone instances is great, FQDN and host name. If you're doing availability groups, then don't forget that you need to make sure you got the listeners in there as well for the encryption, as well as the host names and the FQDNs for the server that's hosting the instances. In the case of failover cluster instances for TLS encryption as well, typically you'll want to make sure that the same certificates across all of them. With regards to that one as well, make sure that you set the read permissions on the private key. Otherwise, SQL Server might not start up, depending on what your configuration is. Those. So when we start moving on to TLS, the versions, yeah, we can talk all the way back to 2008. There's some specific patches that you need to put in place at the highest SP levels. 2016 plus, it's there by default. It's an interesting one. Prior to those CUs and service pack levels, you're not dealing with 1.2 TLS. That's the version you really want to be using, because the others are inherently insecure and can be broken very rapidly with the levels of compute that are available to people these days. So so just bear that one in mind. But like I say, with the combination of things like DBA tools and PowerShell for certificate retrieval and deployment, it becomes very, very quick and easy to do this at scale. Like I say, we knocked out over 100 in a day, doing it manually, just because we're doing a large scale sort of fix in our environment. And it's not too bad. I mean, just remember, it's going to require a restart for it to pick up and work from there. You have got two options as well when it comes to the TLS pieces. Are you going to mandate it, or are you going to leave it as optional? My recommendation is, if you're turning it on from scratch in an existing environment, turn it on as optional first. Not all applications may support TLS, depending on what the OS they're running on and some of the configurations that you've got elsewhere. Little steps: turn it on, start using it where you can. If it's a brand new deployment, force it from the outset. Okay, make sure we're strong on that side of things. So we start thinking about TLS itself. We've got our database server with our databases. We've got our end user devices, for example. What we're looking to do is, if we've got an application server, that type of thing, how does TLS fit into this? Essentially, the piece we're going to be looking at and talking about here is the one that's connecting to the SQL Server, whether it's from a client machine, workstation, management endpoint, application server, web server, whatever. Anything that's coming back to the database engine, that's the traffic we're looking to protect here. The traffic that sits outside of that, that's the interesting thing that you want to be protecting with certificates. So if it's web traffic, make sure you're using HTTPS protocols and things like that. One of the things we do need in the environment, like I said, is a CA, so that obviously all of the devices can go off and verify the certificates they're dealing with. What you don't want to typically do is use self-signed certificates over on the SQL servers themselves, because then you're essentially going to turn around and add the connection string parameter and say, basically, we're going to trust the server-side certificate. We're going to trust the certificate that we're given. Okay. We get the CA in place, and that gives us that one central repository when we can do revocations and all that sort of stuff around those certificates. So if something happens, we've got that ability to do it. The other thing as well is I have seen people using is server certs. Now, a lot of the time, those can be configured for auto renewal. So the default server certificates will auto renew. That's what they're configured to do in the environment. That's a problem for SQL Server, because if you when you punch in the thumbprint, that's essentially stored down in the registry, and SQL Server has got that in, and that's what it looks for. If that certificate comes to the end of its life, it gets automatically rotated. When it finally ages out and expires, then you end up in a situation where nothing can use it, and you end up, anything that is trying to do encrypted authentication, encrypted connectivity to SQL Server instance will start failing. But if you've got things like SCORM or other things monitoring for the expiry of a certificate, again, because it's happening and doing the auto renewal, you're not going to spot that. So that's a gap that you can do. So again, that comes back to having a very specific certificate solely for SQL Server. So we get our CA, we put the certificate and deploy it from the CA onto the SQL Server itself. Do you go for one certificate per instance? It depends how many instances you've got. I tend to avoid instance stacking like the plague, just simply from a management perspective. It depends on how complex you want to make it and how granular you want to take it. Again, if you're retrofitting a very large environment that's legacy, start small and then wind it in. Go from there, really. But again, just assess your own situation and make that decision based around that one. So anyway, once we've got the certificate in place, when we establish communication, they'll go off and validate against the CA. The CA will say, yes, this is good. You can continue. We'll do the encryption, decryption. And we have solid TLS in place there. Okay. Because we're running up on time, we'll just quickly talk about the cloud environment. Fundamentally, the same principles apply. It's a little bit different in the way we're defining software-defined networking up in the cloud. So when we start thinking about when we're doing it in Azure, for example, we create the virtual network. We've got the subnets, and in that sort of scenario, you've got NSGs and things like that. So you've got various other layers of security that will come into it. We've got Azure Firewall. The NSGs it's an interesting one. So network security groups are essentially a form of, I don't want to say a form of firewall, because they don't log anything. They're more another gateway mechanism for allowing traffic in and out of network interfaces or virtual subnets on virtual networks, that type of thing. Okay, and if you're doing anything, so you use Azure SQL Database, for example, you've got the network, you've got the firewall on Azure SQL Database. For the public endpoint, if you're using private endpoints, things like that, you want to be careful on how you're doing all of those things as well. So when we start thinking about the cloud sort of environment, we want to make sure we're planning our subnet layouts, segmentation policy. Don't go hugely granular, because again, when you start thinking about how you're setting this up, the cloud network environment is fundamentally a different thing, whether you're going enterprise WAN, whether you're going a sort of hub and spoke scenario. You just want to be very, very cognizant of that. It can get very complex very quickly, and you don't want to trip yourself up to prevent yourself from doing peering. That's the one. I couldn't remember the word for a moment. Essentially, the way you're peering your networks in hub and spoke models, that type of thing. But again, you've got a wealth of features. Make sure you're using the right one. Okay. I would show you, but I don't know what state Azure's in after it had its little wobble earlier. So I don't have a cloud demo today, I'm afraid. So we'll quickly do some summary, and I'll jump into Q&A quickly. As I said, security is all about layers. Those layers are Swiss cheese. There's holes at every layer. No layer is 100% robust. That's why we've got firewalls. That's why we've got antivirus. That's why we've got so many different things that we put into the mix to secure our system, ACLs and so on and so forth. Okay, line them all up in such a way that you prevent ingress as far as you can. Okay, ultimately someone is going to get in. You want to make it difficult for them, but without putting onerous management layers in way of you doing your job. But conversely, we don't want to leave it wide open, because then we're essentially negligent in the protection and management of the data that we're guarding. I tend to be very explicit about things. This is what we've got. This is how we do it. This talks to this. This doesn't talk to that. Rather than doing it that way around, it's always a case of I'm letting this happen, and unless I've said it can happen, it doesn't. Okay. So we've essentially got an implicit deny on everything unless we've explicitly said so. So, got another question in the chat. On the, oh, here we go. So, would consider encryption for data in transit more important than encryption at rest? Is there any value in encrypting connection for native connections? Yes. Good question. Very good question. I'm of the view that TLS encryption, if it's not on the server, it's more vulnerable. So I would always look to make sure you're encrypting the traffic. So the encrypt connectivity between whatever is talking to SQL Server and the client, that's with the option. If you can force it from the server side and say, if the client cannot support encrypted traffic between me and it on the protocols that we're specifying, I'm not going to do it. If you're in that sort of environment, that's going to make life easier, because whilst it's at rest, we can put more safeguards and compensating controls around it. We make it more difficult to get in there. We've got strong ACLs. We're restricting who has physical access. A lot of the storage devices today, so things like Pure Storage and various other storage vendors, will encrypt the data physically on their media. The issue comes then, the threat vector, if someone manages to connect via a network share and pull a copy of the files, for example. That's when TDE comes into its own, or the encrypt by certificate, the encrypt by functions, or always encrypted. So it depends on your threat, on the particular threat vectors you're looking at, but also your risk appetite and what you view those risks as. Data has always got to leave the server to be able to traverse between the database server and the things that are calling it to process that data. So that's a given. That's a higher risk scenario, because it's got to happen. When you start thinking about whether or not the likelihood of someone being able to gain illicit access to the server to take a copy of the database files, what's the risk appetite? How likely do you think it's likely to be, and make that risk-based decision? I would avoid TDE wherever possible, just simply because of the ramifications it has for the server at large, but also for things like the backup infrastructure, the storage infrastructure. Essentially, it nullifies your compression and dedupe capabilities within many of your storage devices in this day and age. I would tend to, if you're developing a solution from scratch, go down the always encrypted route. If it's a third-party vendor and you don't have that option, then TDS obviously is a tool in the toolbox that we can make use of. So again, it's about just understanding that particular sort of threat vector and where you are with that. So again, it's another sort of woolly it depends, I'm afraid. Sorry about it, Mike. Okay, and with that, we'll wrap up. Thank you very much for having me. I really appreciate you taking time out of your day. So just looking at the other questions coming in. Contact details are there. Feel free to reach out to me. So let's see what we've got coming through in chat. Cool. Greg's done a book on TDE. Well worth a read. Cheers for the link on that one. That's cool. So interesting, complex to implement and support network level security, responsibility for who will do what, another layer of investment. Yeah, it's an interesting one. I mean, this comes down to, like I say, understanding the overall operating model that you're dealing with. I tend to always push for the database team to have, so long as the skill set is there, to have access to manage essentially from the OS up in conjunction with the server team. So essentially, we're able to do a lot of the administrative activities, but we're working essentially in conjunction and collaboration with the server team. So they're the ones that own the policies around what happens at the OS layer, and we dovetail into that. So essentially, they do all the patching, the OS layer and everything like that. They handle group policy, all those sorts of things, but we advise them. So things like making sure SQL Server's got the appropriate rights assignments and group policy doesn't stamp all over that. That comes from us. It's about collaborating and working effectively with those teams around you. We can't work in silos to do effective security. You'll have security teams who sort of sit there and send out diktats and this is how it should be, and they don't necessarily understand technologies or the operating models. And as you said earlier, a couple of comments and questions that they put so many barriers up that it becomes onerous and people will pull their hair out and it causes problems. So all I'd say is look to collaborate. I mean, I would push for more control just so that we can manage these things effectively, but we've got to do it in collaboration with others. Comment around Azure network security being very complex. Yes, it's insanely complex. Software-defined networking up in Azure there's a lot of pitfalls for it. There's so many different ways to achieve the same thing with things like peering, with VPNs between sites and network segments. One of the things it doesn't really handle hugely well is natting in certain scenarios. So again, it comes down to really having to put the legwork in up front when you start designing out your landing zones. Understanding how your network's going to network segmentation, your addressing policy essentially is going to line up. Because if you get that wrong at the outset, it can cause you a huge number of problems. Like you say, I mean, we think the way the NSGs, network security groups, are configured, lots of it's additive. So if you've got network security groups if you're using, for example, virtual machines for IaaS with SQL, if you've got network security groups on the network interface cards and on the subnets, it can become somewhat difficult to troubleshoot. So I tend to let's say pare things back as much as possible. I don't think we've got any other questions in the chat. So Warwick and Martin, is there anything else?
You haven't missed anything, so I think you've covered everything with keeping a good eye on the chat window. So big thank you to John for taking up his time and talking to us from the UK. A big thank you to everybody for joining. Once again, this session has been recorded and will be made available for you to come back and view on the Data Platform Downunder YouTube channel. For next week, we have our third session for the month. And next week's session is on, so that you're all aware, we have, if my internet would work, there we go. So we've got feeding the modern data warehouse. So if that's up your wheelhouse, then make sure you register, come along, and I look forward to seeing everybody in a week's time for our third session in March.
Thank you very much, Warwick. Thank you very much, everyone. Once again, stay safe, have a great time, and speak to you all at some point.
Thanks, everybody. Thanks, John. Talk soon.